Welcome to The Explainer. Today, we're going under the hood, or, well, more like under the floor, of a Tesla Model S to trace its electrical nervous system. We're going to follow the high-voltage power all the way from the plug to the pavement.
74 feet. I mean, can you believe that? That is the total length of that bright orange, high-voltage cable you see snaking its way through the car. It's this complex web that links up 11 really crucial components.
So where is all that cable going? And what is it all doing? You know, if you really want to get how an EV works, you've got to follow the power. It's this whole journey of conversion, distribution, and just incredible speed.
All right, so let's dive in. And we're going to start right where pretty much every EV journey begins, the plug.
Okay, first stop, the charge port. This is the main gate for all the energy the car is ever going to use. But, and this is important, the electricity doesn't just, flow straight from the port to the battery.
From that charge port, you've got these two super thick, heavily shielded orange cables. They're each about 7 feet long, and they run to this component that's tucked away under the back seat. This is where the real magic of charging actually happens.
Okay, so here's the deal. The power coming out of your wall at home, that's AC, or alternating current. But the car's battery, it can only store DC, direct current. So the onboard charger has this absolutely critical job. It has to convert that AC into DC. And while it's at it, it also boosts the voltage way up from 240 to over 400 volts, just to cram as much energy in there as possible.
Now what's really clever here is how this charger adapts. When you're charging at home, yeah, it's working hard, converting AC to DC. But let's say you pull up to a supercharger. That thing is already pushing out high-voltage DC power. So the onboard charger basically says, hey, my work here is done. And it flips a couple of internal switches, they're called contactors, and just lets that powerful DC current completely bypass all the conversion stuff and go straight to the battery. Super efficient.
Okay, so the battery is juiced up. Now what? How does all that power get where it needs to go? Well, you need a central hub, right? A kind of master intersection to direct all that electrical traffic.
And that's where this thing comes in, the rapid splitter. It plugs directly into the high-voltage battery pack, and you can think of it as a really smart, heavy-duty junction block. It is the one and only entry and exit point for all the power in the battery.
And this really shows you just how central it is. I mean, look at this. Power comes in from the charger, goes through the splitter, and into the battery. Then, when you're ready to drive, power goes out of the battery, back through that same splitter, and gets sent to the rear motor. Plus, it sends power on this long 12.5-foot journey all the way to another distribution block at the front of the car.
All right, this is the fun part. Let's see how all this electrical wizardry actually turns into that thing we all love about EVs, right? That instant, totally silent acceleration. This is where electricity finally becomes motion.
So power flows from that rapid splitter to the rear inverter. And right now you're probably thinking, whoa, hold on. Didn't we just spend all that time converting AC to DC to charge the battery? And yeah, you're absolutely right. But here's the crazy part. Big electric motors like the one in this Tesla, they actually run best on AC power. So the inverter's job is to take that high-voltage DC from the battery and flip it back into a perfectly controlled three-phase AC signal. It's this signal that tells the motor exactly how fast to spin and with how much oomph.
Okay, but let's take a step back. We are talking about managing up to 400 volts here, and potentially thousands of amps of current. That is a ton of power. You need some serious safety systems for that, especially if there's an accident or a short circuit. Your standard, everyday fuse? No way. It just isn't going to cut it.
And the engineers at Tesla knew this. They figured out that with this much energy flying around, a normal fuse was just, well, it wasn't predictable enough. In a really bad short circuit, it might not blow fast enough, or maybe not at the right time. So they had to invent something way better, a truly high-tech solution.
And this is it, the pyro fuse. And honestly, the best way to think about it is like an airbag, but for the electrical system. There's a little circuit board that's constantly watching the current. The second it senses a dangerous, catastrophic surge, it triggers a tiny pyrotechnic charge. And that little explosion physically blows the high-voltage connection apart, cutting the power off instantly.
Okay, now get ready for this number. This fuse can break a circuit that's carrying 2,000 amps of current in just 500 microseconds. I mean, that's half of 1 millisecond. It's almost instant. And in a high-voltage system like this, that incredible speed is literally the difference between a minor problem and a potential fire. It is an absolutely amazing way to keep the car and everyone in it safe.
So we've talked a lot about making the car go, but don't forget, that high-voltage system does a lot more than just turn the wheels. It's also powering everything that keeps you comfortable in the cabin and keeps all the other systems running. Hey, remember that super long cable we mentioned that comes from the rapid splitter in the back? Well, this is where it ends up, at another junction block right here in the front of the car. You can basically think of this as a high-voltage power strip, and it's feeding 5 absolutely essential things: the front motor for the all-wheel drive models, the air conditioning compressor, and a couple of different heaters.
And one of those things is the DC to DC converter, which is, I'm telling you, the unsung hero of this entire system. Its whole job is to take that massive 400-volt DC power and step it way down to the 12 volts that everything else in the car needs to run. We're talking about the lights, the windows, the computers, the infotainment screen, all of it. Without this little box, none of that stuff would have any power at all.
So, after following this entire path, all the way from the plug to the battery to the motors to the heaters, you start to see a bigger picture emerge.
And this is the big takeaway, why all this really matters. These core building blocks, the onboard charger that goes from AC to DC, the inverter that goes from DC back to AC, and the DC to DC converter that goes from high voltage to low voltage, these aren't just Tesla things. This is the fundamental blueprint for pretty much every modern EV you'll see on the road today. So if this is the blueprint for today's electric cars, it really makes you wonder, right? What will the power system of tomorrow's EVs look like? When you understand how all this works, you can really appreciate the incredible engineering we have now, and it gives you a foundation to start dreaming about what's coming next.